In this video, I want to talk about using square roots and some square root properties. All right, so first of all, what is a square root? Well, if I have 4 squared, well, that's equivalent to 16. Also, if I have -4 squared, that is also 16. Now, finding the square root is the inverse operation. Okay, so taking the square root of 16, taking the square root of 16 is going to equal 4. Okay, so it's going backwards from here. It's the inverse operation of squaring something. Now, as you can tell, there's going to be 2 square roots. There's going to be 2 square roots for the number 16. There is 4 and -4. Okay? So you might be asking yourself, how can I distinguish between the two? If I'm just taking the square root, how do I know whether the question is asking for the negative square root or the positive square root? Well, there is certain notation to denote each. Okay, so the positive or principal, I think it's that kind of principal, square root is denoted like this. So the square root of 16, that is positive 4, okay? And the negative square root, that is written with the negative sign, 16, and that is equal to -4, okay? So please be aware of this. Do not say that, okay, if the book or if I ask you some question like what's the square root of 64, do not put plus or minus 8, that's supposed to be an 8, plus or minus 8, okay? This is only asking for the principal root, okay? So only the positive. So the answer to this question is only positive 8. The answer to this question is -8, okay? And you'll learn more about this distinction once we get into the quadratic formula and we use it a little bit more. Okay, so let's move on to some examples. The first example involves the product rule. Okay, so if I have the square root of 9 times the square root of 4, okay, I can rewrite that, or the square root of a times the square root of b, I can rewrite that as the square root of a times b. Now this only works, okay, if a and b are greater than 0. Okay, a quick aside, if I had the square root of some negative number, like the square root of 9, okay, and you ask yourself the question, okay, what number squared is going to give me a -9? Well, maybe 3 squared. 3 squared is 9, and -3 squared is equal to positive 9 as well. So there's nothing that is going to square to be a negative number. So we have to be careful when we talk about things under the square root, and for now, they have to be positive. So, in doing this problem, the square root of 9 times the square root of 4, if we look at it, well, this property says that it's just going to be the square root of 9 times 4. So the square root of 9 times 4 is the square root of 36. And the square root of 36 is 6. We could look at it. Let's evaluate these individually and then multiply them together. So the square root of 9 times the square root of 4. Well, the square root of 9 is 3. The square root of 4 is 2. And that is also equal to 6. So this is a nice property, this product rule. And it allows us to split apart square roots into 2 different pieces and evaluate them. Okay? On to the next example. Okay, in example 2, we have to evaluate, so we want to simplify, actually I should say simplify, not evaluate, the square root of 24. I want to use that product rule that we just learned, break this apart, and see what we can do. Okay, so I have the square root of 24 here. Well, I could break that apart into, there's a bunch of different factors of 24. You know, there's 6 times 4, there's 8 times 3, 1 times 24, 2 times 12. That might be it. But that's a lot. So what one should I choose? Well, we're dealing with square roots. The inverse of a square root is squaring something. So what I'm looking for when I'm looking for my pair is I'm looking for a perfect square. Okay? So I want to evaluate this. I want to break this square root up, the square root of 24, into a perfect square times, whatever other number there is. All right? So in doing that, the only pair here that has a perfect square is 6 times 4. So I'm going to break up this 24 into 6 times 4, okay, which, using that product rule, okay, I can break it up into square root of 6 times the square root of 4. All right, well, the square root of 4 is 2. So this is, and I can't do much, right? The square root of 6 is some irrational number. So I can really just write this as the square root of 2 times the square root of 6. And that's my final simplified answer. All right? Let's move on. I want to simplify or add 5 times the square root of 2 plus 2 times the square root of 8. This might seem impossible, but it is not. Okay, so let's look at the first term here. I have 5 times the square root of 2. Well, the square root of 2 is an irrational number. It never repeats and goes on forever. Looking at it like this, the square root of 2 is looking at it at its simplest notational form. So we don't do anything there. All right, what about the next term? Well, we have 2 times the square root of 8. Well, the square root of 8 I can break down. I know that 2 is a factor of 8. So let's break down this square root of 8. Okay, let's break it down into 2 times, well, I know that I can get a square root of 2 out of it. I know that 2 is a factor, and that seems like a good idea because we have a 2 here, and then we can combine like terms. And then I have 2 times what is 8? 4. Okay. Go a step further. I'll have 5 square root of 2 plus 2 times the square root of 2 times the square root of 4. Well, if I rewrite that again, I have, okay, the square root of 4 is 2, and 2 times 2 is 4, so this is 4 square root of 2. Okay, well, I have 4 square roots of square root of 2's, and I'm adding, I have 5 square root of 2's, and I'm adding 4 more to them, so I have 9 in total. So that is my simplified answer, 9 times the square root of 2. The next example involves the quotient rule. Okay, and the quotient rule simply states that you can break up like the square root of a over b into the square root of a over the square root of b. And this is going to become very helpful when we start dealing with quadratics. Of course, keeping in mind that the square root of, b down here cannot be 0 because we have a fraction, and a just has to be a positive number. Okay, so using this quick example, if you wanted to calculate the square root of 25 over 49, you could just break that up into the square root of 25 divided by the square root of 49 and get yourself 5 over 7. Okay, so it's a nice convenient rule that we can use in order to simplify.